Right, hello, my lovely, very close to deadline day mathematicians. So, what I'm going to do, I'm just going to run through an example of how you might use an AI to help you with your study if you are getting stuck and if you just don't know what to do. So, I've got a problem. Sorry, I've got a problem here. I think this is what's going on. That we've got a slope and we've got B is going to slide down, and D looks like a movable pulley. It says movable disc here, but I think it's been called movable pulley as well. And the string then is attached to the ceiling up there, and I'm not sure what to do. Now, this is the third time I'm recording this. First time it worked, sound didn't. Second time the AI would just not play ball. So I'm going to try one more time and I'll post this regardless of what happens. So there we go. I'm just going to copy that image. I'm going to go into my trusty AI and I'm just going to paste the image in. Just give it a second. And it says it's only extracting the text. And let's have a look at what this says. And it's that image there, and what I'm going to say is how to find the tension in the string. And it takes a little while to process. Oh, quicker this time. Okay. And let's see what it says. Now it's going to take a little while for it to go through everything. You're better off not looking at the detail here because you'll go mad trying to follow it. Step 3 solves the equations. So 2.64. So 2.64 was what I got previously. Now let's go back up and have a look and see. We want to see, can we gonna get a handle on, has it got it right first of all, and if it hasn't got it right we need to tell it it's wrong and make it solve it again. So the mass of disk, the acceleration of the disk is A upwards, tension in the string, weight of disk. Now I think there's something wrong with step 1 there, and this is what we have to do. Like, AI is not perfect, but if we're paying attention we can guide it. I think there's 2 T's upwards. Yeah, there should be 2 T's upwards. So we say D is a movable pulley. And see, does that do anything? Instead of even asking it a question, just tell it what's going on. Yeah, I'm correct. Changes. Now let's see, has that worked? What's the answer? 1.17. Okay, key takeaways. So maybe it even might be useful to read the key takeaways first and then go up. So for a movable pulley, the tension acts twice, once from each side of the string, which is the 2 hours we have. Cool. The acceleration of block B is twice that of pulley D due to the string constraint. Always double check the setup, which is very good advice. What does key take away to mean? The acceleration of block B is twice that of the pulley. The statement describes the string is fixed at one end, attached to block B at the other. So this gives you some great examples of what to do now. So this is, I suppose, one of the brilliant features, the things that AI lets us, is this amazing tool that lets us, with the knowledge we have, really increase our detailed understanding of what's happening. It couldn't teach us it from scratch, I think, but if we have some understanding of the situation, we can make it perfect by asking. So let's see. The acceleration of block B is twice that of the pulley due to the string constraint. Kinematic relationship between the pulley and the block B caused by an inextensible string. That just means it doesn't stretch. We have no Hooke's law stuff going on. String is fixed at one end. The pulley D moves upwards with acceleration A, and the block B moves down the incline with acceleration 2A. Like if I'm tired at the end of June, you guys must be wrecked. So, okay, and I think that what happens there, because if D moves up, because it has strings on either side, for every one it moves up, it needs to move 2 meters worth of rope, I think. That's why it's twice as fast. Yeah, because if D moves up 1 meter, there's a meter down here which needs to go up, and then it needs to go up again. I think it'll probably explain it more properly, but for every 1 meter the pulley D rises, the string must shorten by 2, because both sides of the string are pulling. Thus B moves twice as far, which is what I said, only better. And then there's a detailed derivation if you want to. That y double dot thing, you may not have seen that. That's just another way to do second derivative. Y dot would be first derivative. There's a few different ways of dealing with that, depending on whether you're Team Leibniz or Team Newton. Intuitive example. Okay, so if you pull it the wall's end, moves 2 meters. Short. I'm not sure about that intuitive example. That seems more confusing. So it tries things to get some wrong. You might ask for it. So impact on the problem. Okay. Cool. So it does give an idea. So a different intuitive example. Getting fewer and fewer words into this thing. The ladder and the bucket. You're standing on the ground holding a bucket with a rope tied to it. The rope goes up to a pulley disc D, attach the ceiling, then back down to your hand. You pull the rope down by 1 meter. The pulley attached to the ceiling doesn't move. The bucket rises by 1 meter. So that's, yeah. So if you have a rope, you pull it. It'll, for every meter you pull down, the bucket will move up. Okay. Pulley, it's free to move. So for every 1 meter the pulley rises, it's 1 meter from the ceiling side and 1 meter from the bucket side, which means 2 meters have to go down. B has to move down 2 meters. Okay, I think that's a better analogy. Okay, so that's step 1. Now we're pretty sure step 1 is bang on. So let's have a look. Where did we go? Key observations. Where was my first question? Oh, okay, where were we? We had up here. D is a movable pulley. Okay, let's see, does this seem to make sense? So, 2t minus mg is equal to the acceleration, and we get our equation. That looks like it makes sense. Then block B, inclined plane, acceleration of block B, normal force. So the normal is perpendicular to the surface. I don't know if your teachers would use the word normal, but if you do some fancy maths next year, you will see the word normal a lot in kind of mathematical methods and vector spaces and stuff. So yeah, you'll get that. So then the weight of the component along the plane is mg sine 30. Normal force is cos 30, which I think is correct. Again, you do the diagram, you'll see. Then we have that. The acceleration is 2a because it has to be twice of what d is doing. I suppose probably normally we'd call the acceleration of the block B a, and then the d would be half, but this is exactly the same thing. That looks right. I'm sure there could very well be a mistake. I can't see it, but the logic does seem sound. And we go, okay, you're satisfied that that's a way to get the answer. And the key takeaways are great. And ask it to explain itself, because that's what, it's there, and use it to make you better at what you need to be good at. So I'm going to look at one more little problem. This thing from was it last year or 23 about opal mining, and new problem. What is the inhomogeneous part? Because the problem is this. While that's doing, I think I'll just. It's a difference equation. Get your m plus 2, your n, your n. So it's a second order difference equation. And it has this extra bit, this minus 2m plus 2 bit. So it has an inhomogeneous part. It says it there. What the hell? Okay, let's see what it has come up with. Okay. Well, I was going too far. Okay. We are given a second order linear inhomogeneous recurrence relation. Recurrence relation is another word for difference equation, so it depends what your teacher has called them. We need to identify the homogeneous and inhomogeneous parts, solve the inhomogeneous, find a particular solution, combine the homogeneous and particular, and apply initial conditions. So that's really nicely laid out. There's just 4 things we need to do. Are you okay with 1 or 2 or 3 or 4? So can you identify which bit's which? And the homogeneous part is the stuff with the PNs, and the inhomogeneous is the other stuff. I've never seen the word forcing term before, and so I don't want to mess up with my flow here, but I would say, what on earth is a forcing term? So then, and he did a bit of simplification here, which I'm not sure I would bother with yet. So solve the inhomogeneous, so you get your answer. Now again, I feel like that's wrong, but maybe it's not, maybe it's perfect. So you solve that by creating a quadratic, getting 2 answers, and then the homogeneous solution is that bit. Then you need to deal with the particular solution for the inhomogeneous part, which is an exponential, so it has to be an exponential. Put step 4, combine that in, so you have this. The general solution is this. It's the inhomogeneous and homogeneous parts stuck together. Get your answer. Get A and B, and then check. And again, key takeaways. And then maybe you could say, so what are the so let's say what I want to ask it is, what are the particular solutions you have to know when? So how do I know what type of particular solution I should use in an inhomogeneous recurrence relation? Sorry. So because here it just went 2 to the power of n, so how to choose the form, and it will tell you how to choose the form, and we'll give you examples. So in this case, it's an exponential. And there's a special case there. Then if it's a polynomial, you do something else, or if it's a bit of both, you can do something else. And it gives you a general way to figure out what the possibilities can be for an inhomogeneous part. I'm going to stop there because it's getting far too complex. The inhomogeneous part will be much simpler, and I would be mind-boggled if it was a trigonometric one, or if it was something by a polynomial. So, but I hope that this has just been enough of a taste that you can use AI to help you understand better, so that you can have the words and have the kind of the structures, the mental structures of how to ask yourself these questions in the exam. Just when you are dealing with it, don't trust it. If anything looks weird, ask it to explain itself. And then if you want more detail, just say, what's part 2, what's part 3, how do I do this? Could you explain to me why did I multiply by 5 in step 1 there, whatever. Just ask it and it will tell you why. But I hope that's been useful. Just use it, this great power, great responsibility thing, but use this great power for good rather than evil.